Welcome to Study Loop.
Hello everyone. As shown in the figure, when the 18 kg wheel is attached to the balancing machine and made to spin at a rate of 12.5 revolution per second, it is found that the forces exerted by the wheel on the machine are equivalent to force coupled system consisting of a force of 160 Newton J cap applied at C and couple MC 14.7 Newton meter K cap, where the unit vector from triad which rotate with the wheel. Part A. Determine the distance from the axis of rotation of the mass center of the wheel and the product of inertia Ixy and Izx. If only two corrective masses are to be used to balance the wheel statically and dynamically, what should these masses be at which point of the at which of the points A, B, D or E should be placed? Let us see here. Start solving it. Very lengthy question. To explain the question, it is very lengthy. Given already mass is 18 kg, mass of the wheel 18 kg. Again I am writing, and we are writing angular velocity in vector notation 25 into 12.5 radian per second I cap. So it would be 78.54 radian per second I cap. Now first part, the force coupled system acting on the wheel. Is F dash minus 160 Newton J cap and M dash C minus 14.7 Newton meter K cap. That is given to us. F dash will be M into normal acceleration, which is M R omega square. So R vector can be written as yj cap plus zk cap minus F upon M omega square. So y coordinate of center of mass will be minus Fy upon M omega square, Fy having the value 160 upon M, mass is 18, omega is 78.54 whole square. So on solving it, you will get 1.441 10 to the power of minus 3 meter, or you may write by coordinate of center of mass 1.441 millimeter. This is one of the answer of part A. Now Z will be Z coordinate will be minus Fz upon m omega square z is 0. So you may write z coordinate of center of mass is 0. Now we can find angular momentum about C. It would be Ix omega I cap Ixy omega j cap minus Ixz omega k cap. M dash C moment of couple about C, rate of change of angular momentum about C plus omega cross Hc. This is 0 because it is rotating with constant angular velocity. So it is 0. Omega is omega I cap. Hc is already I have written, substitute the value Ix omega I cap minus Ixy omega j cap minus Ixz omega k cap. Now find the cross product. You will get m dash c by j cap m dash c z k cap to be Ixz omega square j cap minus Ixy omega square k cap. So from this equation you may write moment of inertia of x by 2b minus m dash c z upon omega square m dash c is minus 14.7 upon omega square 78.54 square. On solving it, this value will be 2.3831 10 to the power of minus 3 kg meter square, and Ixz is equal to m dash c x by upon omega square. This value is given 0, so we can write Ix by 2b 2.38 10 to the power minus 3 kg meter square, and Ixz to be 0. So these are the answer of part A. Now we have to solve the part B. Let us see here. Part B. Position for the valence masses. We have YA is equal to YB is equal to minus YE minus YD is equal to 182 millimeter. You can see the figure, that is 0.182 meter. Similarly, minus XA, X coordinate of a point, Y, B, E and D, 75 millimeter or 0.075 meter. valence masses must be added to move the mass center to point C to reduce the product of inertia to zero. What I have said, I am writing here. Valence masses must be added to move the mass center to point C and reduce the product of inertia to reduce the product of inertia to zero. So MA, YA, MB, phi B, ME, YE plus MD, YD plus My must be zero. All these having the value 0.182 meter. You may write MA plus MB minus ME minus plus MD plus 2.3831 10 to the power, sorry, minus ME minus MD plus 18 into Y. We have calculated 1.414 10 to the power minus 3 to be 0. So this equation can be written as MA plus MB minus ME minus MD is equal to minus 0.1425 kg. Say this is equation 1. Now MA XA YA plus MB XB YB plus ME XE YE plus MD XD YD plus IXY to be 0. So from here XA YA product of all these we can take common because each having the same value. So you may write minus MA plus MB minus ME plus MD plus 2.3831 into 10 to the power minus 3 must be 0. So you will get minus MA plus MB minus ME plus MD to be equal to minus 0.17459 kg. This is your second equation. To solve equation 1 and 2, set MB0 to solve equations 1 and 2, set MB to be 0, let MAD is MA minus MD, then MAD minus ME is equal to minus 0.1425 minus MAD minus ME is equal to 0.17459. So from here you will get MAD is equal to 0.01605 kg and ME is equal to 0.1585 kg. So set MD is equal to 0. So MA you will get. Method is the same. So one by one set MD is equal to 0. So MA is 0.01605 kg. So here we can say mass at E must be 158.5 gram and mass at A must be 16.05 gram. That's all for it. Thanks for watching it.